What if I told you that a football, the instant it leaves this man's boot, is moving faster than a cheetah at full sprint? Cristiano Ronaldo doesn't just kick a ball, he launches it. So today, let's actually measure it with real physics and no boring math. You've all seen it. He steps up, takes those long strides back, plants his foot, and the ball just explodes off his boot. It sails over the wall, and then, at the very last second, it dips viciously into the top corner. The keeper doesn't even move. It looks like pure magic, but isn't magic. Every single thing that ball does is physics, and once you see the numbers, it's even more impressive than the goal. So here is the one question we're going to answer today. With how much force does Cristiano Ronaldo actually hit a ball? And I promise you, by the end, the answer is going to sound completely insane. We're going to compare it to a cheetah, a fighter jet, and a 20-story building. Stick with me, because the numbers are wild. Let's draw what actually happens. The ball starts here at his boot. It rockets up and over the wall, reaches the top of its arc, and then drops like it hit an invisible wall in the air, curling down into the net. The whole journey takes less than 1 second. So our job is simple. Figure out how fast it's going and how hard he had to hit to do that. First, the speed. When Ronaldo strikes a free kick with everything he has, the ball leaves his boot at around 130 kilometers per hour. Let that sink in. That's the speed of a car flying down the motorway. It is faster than the fastest animal on land. A cheetah tops out near 120. Ronaldo's ball would pull away and leave it behind. And to be clear, this is not just a fast kick. It is a completely different league. An average person messing. Now, here's the part that blows my mind. How long is his foot actually touching the ball? Watch in slow motion. The contact lasts less than 1/100th of a second. Blink, and it's already over 100 times. In that tiny flash, his foot has to grab a still ball and fling it up to highway speed. And that is exactly where force comes from. And in that 100th of a second, the ball isn't even a ball. Watch the slow motion frame by frame. It squashes inward by up to 1/4 of its width, flattening against his foot like a stress ball before violently snapping back to round. That snap is the ball behaving like a loaded spring, throwing itself off his boot and adding even... Here's the simple idea behind force. Force is just how fast you change an object's motion. Take how heavy the ball is, times how fast it ends up going, and divide by how long you pushed it. The ball weighs about 430 grams. We send it to 36 meters per second, and we do it in 1/100th of a second. Plug that in, and out comes a number that does not feel real. The answer is over 1,500 newtons. 1,500 newtons squeezed through the top of his foot in 1/100th of a second. Physicists have another way to size up a hit like this, momentum. It is just mass times speed, and for this ball, it comes out around 15.5. Here is why that matters. Imagine trying to catch it with your bare hand. Your fingers would have to absorb all of that momentum in a fraction of a second. That is exactly why a ball struck this hard can sprain a finger or knock you flat. And that power doesn't come from his leg alone. Slow it right down, and you see the whole body fire in sequence. The plant foot slams into the ground, the hips whip around, then the knee, and the foot snaps through dead last like the tip of a cracking whip. Each link passes its speed to the next, so the foot is traveling fastest at the precise instant it smashes into the ball. Two whole people standing on the ball in 1/100th of a second, and we're only getting started. Let's talk about acceleration, how hard the ball gets shoved. Going from a standstill to 36 meters per second in 1/100th of a second means the ball feels about 370 G. 370 times the pull of gravity. A fighter pilot starts blacking out at 9. A brutal roller coaster gives you about 5. For 1 instant, that ball is shoved harder than almost anything a human ever survives. 370 G from a guy in shorts. Okay, Cristiano, calm down. Now, energy. How much punch is stored in that flying ball? About 280 joules. Here's what that actually means. It's the same energy the ball would have if you dropped it off the roof of a 20-story building and let it slam into the pavement. Ronaldo packs a 20-story drop into 1 swing of his leg. Now you'd expect a hit this violent to heat the ball up. Here is the surprise, it barely does. Even if every single joule of that impact turns straight into heat, the ball would warm by less than half a degree. A top-level football is built to be springy, so it hands almost all of that energy back as motion, not heat. So where does the energy go instead? The ball stores it. It squashes like a trampoline, and the pressurized air trapped inside acts as a powerful spring that throws it straight back out as speed. Compare that to a squash ball, which is deliberately bad at bouncing. Players have to smack it for minutes just to heat it past 40 degrees, so it works at all. Same physics, opposite design. But here's my favorite way to see it. Power is energy delivered per second. Because he dumps all that energy in 100th of a second, his leg, for that instant, is putting out around 28,000 watts. That's about 38 horsepower. For one blink, Ronaldo's leg matches the engine of a motorbike. So, just how far could a strike like this travel? Launch it at the perfect angle with no air in the way, and the ball would sail about 130 meters, longer than the entire pitch. In the real world, the air drags it back down to around 50 or 60 meters, which is exactly why Ronaldo will line up shots from distances where most players wouldn't even bother. And here's a fun gut check. A football actually isn't the fastest thing humans launch. A big tennis serve flies past 200 kilometers an hour, and a driven golf ball tops 270. But those use a racket or a club as a long lever to multiply speed. Ronaldo does it with a bare foot and a ball that weighs 10 times more. That is what makes his numbers so ridiculous. And if you're wondering, yes, getting hit flush by this ball carries roughly the same energy as a heavyweight boxer's punch. The difference is that a boxer spreads it across a big glove. Ronaldo concentrates the whole hit into one small, hard ball. That is why a free kick to the body genuinely knocks the air out of a professional athlete. People always ask, could a kick like this actually hurt someone? Without a doubt. A ball to the head at 130 kilometers an hour lands with over 1,000 newtons, all focused on a tiny patch of skull. There are real, documented cases of players being knocked unconscious by a single shot to the head. This is not a toy. It is a genuinely dangerous amount of concentrated energy. So we know how hard he hits it. But why does it move like that in the air? Why does it suddenly dip? This is the famous knuckleball, and the secret is the spin, or really, the lack of it. Most players curl the ball with heavy spin. Ronaldo does the opposite. He strikes it dead center, so it barely spins at all on its way to goal. Here's why that matters. A ball that isn't spinning leaves the air behind it confused. The airflow can't decide which side to peel off from, so it flips back and forth, shoving the ball sideways with a force of a few newtons that keeps changing direction. The ball literally wobbles and swerves on an invisible, shifting cushion of air. Even the keeper has no idea which way it'll jump. And then there's the dip. As the ball slows down in flight, that wobble grows, and the air pressure on top wins. The ball drops out of the sky far faster than gravity alone could pull it. That late, vicious dip you see, ducking under the bar right as the keeper commits, that is the air doing the work. Ronaldo just aims it. There's also a perfect spot to strike the hard ridge of bone across the top of the foot, the instep. Catch the ball right there, and almost none of the energy is wasted. Catch it a centimeter too high or too low, and the ball squirms offline. The energy bleeds away as wobble, and the shot dies. Ronaldo finds that sweet spot again and again, on demand, under pressure. No spin, confused air, and then it just drops. That's the knuckleball. Honestly, it's beautiful. There's one more enemy fighting the ball the whole way: air resistance. Even a strike this hard is constantly being slowed by the air it's smashing through. It leaves the boot at 130, but by the time it reaches the net, it's lost a real chunk of that speed. The faster it goes, the harder the air pushes back. Now put yourself in the keeper's gloves. From 25 meters, that ball reaches the goal in well under a second. A human needs about half a second just to react and start moving. So he has almost no time, and the one piece of information he's using, the ball's path, is a lie, because halfway there the air makes it swerve and dip. He's beaten before he jumps. And it gets even more brutal up close. On a penalty struck this hard from 11 meters, the ball crosses the line in roughly a third of a second. That is quicker than you can blink, never mind dive. So physically, a keeper cannot actually react to it in time. When they do save one, they aren't reacting at all. They have guessed aside and committed before the ball is even struck. So why can Ronaldo do this when almost nobody else can? It really isn't magic, and it's barely even talent. It is repetition. He has taken thousands upon thousands of free kicks in training, grooving the exact same motion until his body can fire that perfect whip crack without even thinking. Physics hands every player the same rulebook. He is simply the one who drilled it until it became automatic. So let's put it all together. 130 kilometers an hour, over 1,500 newtons of force, 370 G of acceleration, the power of a motorbike engine, all released in a single hundredth of a second on a ball engineered to fool the air itself. That is not luck, and it is not just talent. It's thousands of hours of practice, lining up perfectly with the laws of physics. So the next time you see Ronaldo line up a free kick, you'll know exactly what's coming. A motorbike's worth of power, folded into 1/100th of a second. If this changed how you watch the game, hit subscribe because we break down